Okay. That's kind of bad crazy when I factored this as 1 plus and 1 minus the cosine. It'd be 1 plus I cosine, 1 minus I cosine, and that's not helpful. So it's just basically 1 plus cosine. Forget about the square root or anything else. Over the square, 1 minus the square root of the cosine. Now, playing around with that for about 10 minutes, suddenly realized I'll come back to this. And putting those things together in a way that I'm not going to have time to put up, but hopefully we'll do it later. Within any narrow strip here, okay, what I get when I do this, and this area here, pretty much approaches an integral of 4 over theta to the 4th. Not 4 over theta, sorry, 4 over theta, d theta between here and here. And of course, that's going to give you the natural log of theta. And as theta approaches, as this limit approaches 0, this would, I'm not going to write out, it's a limit as the lower part of your integral approaches 0. You end up with the natural log of theta, negative natural log of theta, which as theta approaches 0 approaches infinity, so that proves this area does become infinite. Now, why did we do that? We did all that to show that in the limit as b approaches a, this integral gives us an infinite result. And that's just based, again, on the idea that as we approach the boundary of the loop from inside or from outside, as far as that goes, the loop approaches a straight line which will have a magnetic field, the magnetic field of which in the vicinity is inversely proportional to your distance from the loop. So as you approach the loop, that inverse proportionality approaches infinity and confirms this vertical asymptote. Now again, I'll try to run through the details of this because it's really pretty much stuff you should understand based on Calculus 1. We're using the fact that as theta approaches 0, the sine of theta approaches theta, and expressing this in terms of sines and so forth. Okay, well, that gives the plausibility. I'll come back, and when I do, I'll hopefully have time to give you the details of this reasoning, but I've proven to myself that this integral approaches 0, as I know it must, or as I think I know it must. I'm going to do the numerical integration and get this curve, and hopefully be able to, let's get L-O-U-P, hopefully be able to post a copy of that curve, which ought to be fairly easy.